There are a number of options available to you when deciding on the best chart or graph for your assignment. The great thing about PictoChart is that when you input your data the way you intend for it to be analyzed, it limits the options to the graph types that it thinks would be most beneficial for your dataset. As you can see, for my numbers, it only lets me choose between the bar graphs here, the line graphs, and the dot plot. Now there are vertical, triangular, and horizontal bar graphs, which are great for side-by-side comparisons or time changes, but they're best to use when the differences are larger, like between 2005 and 2015, because when the data fluctuation is small, it's harder to discern, which you can see because you can't even see the one startup in 1995. Now, line graphs and area graphs, these two right here, are my personal preference for the dataset, just because they're good for depicting gradual change as well as faster change, of which my data has both, as you can see between 2000 and 2005, where the difference is just 10 startups. Now, the reason that I would choose a line graph over an area graph is because the latter is better for comparing two different sets of data on the same plane. So, it's meant for you to be able to better visualize the obvious difference in the contrasting data sets, which is why I would prefer the line graph because I only have one data set. Now, the dot plot is just a regular graph that plots your data without showing reason or pattern, which if you don't have reason or pattern for your data points is great, but for mine I'm supposed to show growth, so I need that line. Now, once you've chosen your preferred chart, say I've chosen the vertical bar, just because, you can modify and edit its visual appearance. There are simple edits like changing the color preference. Let me see, right here, settings, changing the color preference right here, say I want it to be pink. Now, you can also decide where you want your legend placed, which is right here, so mine's on the bottom right now, say I want it at the top. You can change whether or not you have an axis, so it's these, the Y and the X axis, say I want them gone. Or a grid, which is pretty fundamental for my data because it's helpful for noticing distinctions. But for some data it might not be. Preferably for my data, a grid between 50s would be more preferable, but this is the only option that it provides for me. Now, there are advanced settings, which aren't always necessary, but here's a situation where it might be. The growth of startups developing AI isn't static, it grows annually, and right now it's estimated to 14 times that of which it was in 2000. That means that it's somewhere, as of recently, closer to 700 startups. Now my dataset only goes up to 2015, so if I wanted to point out how much the number has grown since the data was last updated, all I have to do is change the y-axis coordinate max right here, where it says amount, to 700. So put in 700 to showcase the estimated growth. So you can see that 500 is where it's left off, but there's room to grow till 2018 or 2020. Now, this isn't always going to be a necessary step in your graphs and charts, but there are times when this can bring your chart to the next level analytically and visually. Now, I'm going to change this data to a sample set, so I can show you all the other different types of charts you may need to work with. So now I've gone over all the bar graphs and the line graphs and the dot plot, so the next step in all of these is a pie chart. Now, pie charts are really specifically for showing parts of a whole. So if you have a percentage data that adds up to a whole, or 100%, a pie chart might be the best fit for you. Okay, so imagine with our data set right here that I created, that in 2011, Professor Mueller only allowed these 3 infographic topics in a class of 60 students. A pie chart would show what percentage of students in that class of 60 people in 2011 chose self-driving cars, healthcare robots, or hate speech detectors. So as you can see with the pie chart, provided that 30 of the 60 students, or 50%, chose hate speech detectors. So if your data is to prove those percentages, this is a great fit for you. Now, the next one is an overlapping Venn diagram. It's a bit of an obscure chart, but it's mainly meant to showcase commonalities, so as to prove how some aspects of a dataset or object or concept is unique, and how it is the same. Personally, it's not a favorite of mine because it can confuse the reader if used unnecessarily or improperly, so double check to make sure your data is a perfect fit for a Venn diagram, because if it is, then it's the best chart for you to prove those commonalities. Now the next one is an icon matrix. Now, the icon matrix works similarly to a pie chart, where it showcases the percentage of a whole that each data represents. But it can be more visually appealing than a pie chart because you can actually edit each point to be a representative of your topic. So say with this topic, with AI, I wanted to do each data set as a robot. So I input robot, and I get these 4 choices and say I want this one, or this one. Now, this is what your data is going to look like, which can be more fun or visually appealing if you want your infographic to be more fun. Now, I'm going to go back to the pyramid for the next chart. Now, the next one is a gradient hierarchy, which is just another version of an icon matrix, but it's better for laboratory examples, so not necessarily AI, but it's just to showcase, say, water dilution or element mixing, etc. Like if you're trying to show how much of each data point fills up a hole of something, this chart would work. If you think it works with your data set, it could be a good fit. Now, the gauge and the donut are really just visually altered pie charts, so that's just a matter of preference. And the swatch is a mix of a pie chart and a bar graph, but it doesn't show percentages like a bar chart, and rather shows a visual difference between data the way a bar graph would. So imagine it as just like a leaning bar graph, but it would show 100%. So if 60 of those students had chosen hate speech detectors, there would have been nothing here, and this would come full 180. Now, lastly is the progress bar, and it's exactly what it sounds like. It's meant to depict the progress your data has made. For example, if you remember the previous data set, where by 2020 there would be 700 startups developing AI, but as of 2015 there were only 500? Well, if I put that data on a progress bar, what it would show is that 2015 relative to 2020 is 71% achieved. So that's really the whole point of a progress bar. If you need it, it's a great way to showcase the progress that something has made in AI. So these are all the charts available to you on PictoChart, which is more than enough, and settings right here is how you're going to edit and change anything you want. Now the only one where you can decide your shape and whatnot is the icon matrix and the gradient hierarchy. Thank you for listening.